All right, it's lesson 30. And in lesson 30, we take a look at some of the properties that the definite integral has. And we're going to be very, very geometric about this. We're going to look at these integrals in terms of area. We're going to come to grips with some of the things that are true about them, do a few examples, and then head to class. That's the rough idea. So let's play. There are some properties that the definite integral has. Oh, golly. One of them is that we know what the integral from a to a of f of x dx is. So if we have some function from a to b, that's great. But if we have the function only going from a to a, that's asking for this. I'll even make it more specific. It's this area. Well, that's the area of a vertical line segment, and the area of a vertical line segment is 0. If there is no width to the subinterval, then there is no delta x, so all of the rectangles have area 0. Also, we know how to talk about the integral from b to a in terms of the integral from a to b. If you go right to left instead of left to right, then all of your delta x's are negative because you're heading this way. If you're heading left to right, all your delta x's are positive. If you're heading left, all of your delta x's are negative. So the integral from b to a is the same as the integral from a to b, but negative. They are equal with opposite sign. Third, what happens if we add two functions together and then take an integral? Well, an integral is a sum. So we're adding up a bunch of these things. But adding up a bunch of adding ups, we can just add these all together and then add these all together, and we're fine. Because we're adding a bunch of sums. So we can add these, add those, and put them together. Similarly, if that's a minus sign. What happens if we take this function and stretch it vertically by a factor of c? What does that do? Well, it makes all the rectangles c times higher than they used to be. And if all of the rectangles are c times higher than they used to be, then the sum is c times higher than it used to be. One more. The integral from a to b of f of x dx plus the integral from b to c of f of x dx. Well, what is that? Well, if you take the integral from a to b of f of x dx and add on the integral from b to c of f of x dx, you should get the integral from a to c of f of x dx. That almost makes sense. It turns out that that makes sense even if, oh bugger, even if c is over here. If you take the integral from a to b, that's this big red area, this big integral from a to b. Then you take the integral from b to c. The integral from b to c is this area, but it's negative because we're reading from right to left. So we take this big, large red number, subtract out a blue number. Yeah, that probably equals this thing sitting right here. That almost makes sense. Okay, so suppose that the integral from 1 to 5 of f of x dx is 4. The integral from 2 to 5 of f of x dx equals 1. The integral from 1 to 6 of g of x dx is 12, and the integral from 2 to 6 of g of x dx is 5. Find the integral from 1 to 2 of f of x plus g of x dx. What in the world is going on here? Well, we have some information about two functions. We have some information about an f of x function on this interval and this interval, and we have some information about this g of x function on this interval and this interval. So what do we do to put it all together? Well, this integral that we're trying to find deals with the sum, but this is a sum of sums. So we can break this up. We can break that up into two integrals. Well, that's fine. I don't have a problem with that, except that this is 1 to 5, and this is 2 to 5, and that's 1 to 2. And this is 1 to 6, and that's 2 to 6, and that's 1 to 2. But you're probably already 3 steps ahead of me, because you know that the integral from 1 to 5 for some f of x, this integral is 4. But you also know that if we cut things off from 2 to 5, oh, well, that's terrible. So the whole thing is 4. From 2 to 5, that's 1. So if the whole thing is 4 and from 2 to 5 is 1, this must be 3. And you know similarly down here, if the whole area is 12, but from 2 to 6 is only 5, then from 1 to 2 has to be 7. So we've got 3 plus 7, and that's 10. We don't have to know anything about what the equations of the functions are. We don't have to know what the shape of the graph is. We know if we know the area from 1 to 5, and we know the area from 2 to 5, then we know the area from 1 to 2. If we know the area from 1 to 6, and we know the area from 2 to 6, then we know the area from 1 to 2. Okay? Okay. One other thing for us to talk about before we go. The average value of a function. So let's see. Find the average value of f of x equals square root 16 minus x squared on 0 to 4. Well, it's a very odd thing to think about. It's a very odd thing to think about. So you'll remember the function. It's actually this function from a previous lesson, right? So when you took averages when you were younger, the way that always went was you took a sum of a bunch of things. Oh, wow, so sorry. You took a sum of a bunch of things and divided it by how many things there were. But here, between 0 and 4, there are infinitely many points. So you're trying to add up infinitely many things and divide by infinity. That's absurd. It's absurd. So instead, when we're trying to find the average value, we instead do this thing. We take the integral value and divide by how long the interval is. We take the integral value and we divide by how long the interval is. Why? Well, let's see. What does that do here? You will remember from a previous lesson that this has the value 4 pi. What does that 4 pi mean? That 4 pi means that this area right here is 4 pi. But what if we built a rectangle with the same width, this same width, whose area was also 4 pi? Let's pretend that the purple rectangle had the same area as the green sector here. Well, if that's the case, if green and purple have the same area, then this height right here is my fave. And it kind of makes sense if the purple area is the same as the green area, that that value would be about at pi, because that's 4. So this is 3-ish for sure, even on a cruddy picture. So when we try to find average value of a function, we take the value of the integral and divide by how long the interval is. Okay? More to talk about when we gather in class. We will see you then.